the sharks. And fish, pelagic or reef, furtive, curious, hungry. In the deep, the shallow about the corals, soft and hard, in the known and unknown. In the vastness, here, there, we are one. 250 kilometers east of the northern coastline of Isabela and Aurora, on the biggest island of the Philippines, Luzon, lies a seismically active underwater region nearly as massive as Luzon itself.
This is essentially an unexplored frontier of the Philippines.
This was part of the high seas, unclaimed and unprotected.
This is Benham Bank. It is part of the Philippine continental shelf and is made of mesophotic reefs from 50 to 150 meters deep, and largely unknown, up to possibly 5,000 meters deep.
There was enough evidence to show that it was connected to the Philippines geologically and geomorphologically, therefore was part of our continental shelf.
Expanding the Benham Rise territory of the Philippines by an additional 13 million hectares.
Benham Rise, pristine territory given to the Philippines by the United Nations in 2012.
First fully successful expansion of Philippine territory and jurisdiction, fully in accord with international law.
Changing the archipelago.
The Benham Rise covers a very large area, accounts for almost 30% of Philippine exclusive economic zone. So potentially it can provide a lot of resources for the Philippines.
It becomes part of the area where the country is responsible for in terms of two things, protection, and of course, we're also given the right to utilize the resources in Benham Rise.
And set to change lives.
It's like an extension of the resource base of the country. And these resources are mainly the resources of the seabed, which include non-living resources especially, so minerals and any petroleum that is locked in the seabed.
In its vast depth, how else will it change the Philippines and the Filipinos?
I think we should be really proactive in learning about our environment.
Exploration is great for many reasons. It allows us to expand our imagination about what's possible.
Fisheries and algae experts, microbiologists, oceanographers, ecologists, and technical divers have come together to explore Benham Bank, the shallowest part of the plateau in the northern part of the Philippines.
We're here to explore that possibility, to try and find out what's living here and just learn more about this new resource that's available to the country.
The initial exploration by the National Mapping and Resource Information Administration began in 1999.
The expedition is a venue for collaboration. In our case, we are now collaborating with scientists of different members of the scientific community of the academe. We are also counting on the skills of our partners from the Philippine Navy and the Philippine Coast Guard.
In the unknown deep, with its known dangers, exploration poses serious challenges. Where the open seas can be harsh and violent.
On and off the boat in rough seas is quite a challenge. Probably the biggest challenge we face is strong currents.
The undersea can be extremely harsh and even more forbidding.
The Benham Rise can be quite difficult to sample. That's because it goes from quite shallow water of 50 meters, potentially down as deep as 500 or 600.
Challenges with depth are always there. Obviously, the deeper we go, the longer we stay, the challenges increase exponentially.
Human observation and reason may be the most important tools in the study of our underwater world.
What is challenging is to make it safe. So we need to have the right amount of bailout gas. We need to make sure if there is a problem, we have the backup, the redundancy, and we do that through the team and with the right gases and the right planning.
But in these unforeseeable and severe underwater conditions, divers are the most limited, as well as the most at risk.
So the challenge of diving on Benham, I guess, is the depth and the length of time we need to spend at the bottom to get the footage. So basically we have two problems, which is nitrogen narcosis and decompression. So the equipment we're using for these dives is centered around closed circuit rebreathers. We keep on rebreathing the gas, and the only gas we use is what we actually metabolize inside our bodies, which is fractional. So whereas a normal diver on two big tanks goes down, maybe gets 15 minutes bottom time, in theory, we could go down and spend hours and use very little gas. So it makes the dives possible It extends the gas a long way. It also makes decompression a lot more efficient because we can use the right gases throughout the dives. Most of our dives, as I've said, are in the 2 to 3 hour range total time, and that gives us between 30 to 45 minutes at the bottom.
Where human capacity ends, technology begins.
You can't get any better than having a diver at the site. But when the depths get too much or the divers can't stay very long, like here we're working in deep water, the ROV is very useful because it can stay down for hours. It doesn't have to worry about decompression.
The ROV is like you're diving without getting wet. You get to spend a lot of time underwater to see a lot of the ocean floor and all that it has.
An ROV is very useful because it's unmanned, it's operated from the surface, it's remotely operated. You don't have to worry about dive times or depths. It's much safer than putting divers in the water in this situation.
So when it drives, you drive with it, your eyes are on deck. When there are interesting things, you can stop and you can take a look at it more closely. You can take more pictures. And then all throughout the dive, that is actually documentation that is saved. And that is your permanent record of what it is at that specific time.
So basically what we did is surveyed a 15-kilometer stretch of the ridge, dropped ROVs, and video recorded the benthic community.
Managing this deep-sea technology can be a serious challenge too.
The worst thing that could happen to an ROV is probably entanglement of the umbilical. Tether management is very important. It's not the ROV that gets in trouble, it's the umbilical. It gets wrapped around a rock, or it might float into propeller and get caught in the propeller. If the ROV gets chopped off, you lose all power, so you can't control it any longer. You can't see what's going on. You can't drive it where you want to go. You can lose the ROV. So tether management is very important.
In this 15-kilometer ridge, we identified 5 stations where we initially sampled and then dropped the ROV for more than an hour, or at least an hour. And based on the 1,000 photos that we got, we estimated benthic cover and came up with general categories just to characterize the bottom community of the ridge.
To further understand this terrain and the life it supports, BRUVs were also deployed.
BRUV stands for Baited Remote Underwater Video System. And what we're effectively doing is putting a camera system down with a bit of bait out in front of it, very much like a fish trap, except rather than catching the fish, they're coming into the camera to the bait, and consequently we get many more species, we get many more fish, and we have a lot more statistical power to detect changes both spatially and over time. So each of the BRUVs is equipped with a stereo video system, and stereo video is 2 cameras. We know the distance between the cameras, the angles, and using what is essentially trigonometry, we can calculate the distance to a fish and therefore also its length.
Our primary goal here as part of the BRUVs team is to be able to describe the fish communities of the peak of the Benham back. So if you're able to describe them in terms of composition, what types of species are here, and if you're able to quantify the numbers and also estimate biomass, then you would have a better picture of the structure of the fish communities at these reefs. For this mission, our BRUVs are underwater for about 7-6 hours at a time because we drop them early in the morning and wait until late in the afternoon after all the other research activities are done before we retrieve them. But in actuality, we're probably saving or getting about footages of about 3 to 4 hours only because of battery life and also media card limitations.
And just like the ROVs, the BRUVs can be difficult to operate.
So deploying BRUVs in deep water means you have a number of challenges. The first one is lighting. As soon as you get over around about 80 or 90 meters, you can't use natural lighting to record. We've equipped the BRUV systems with blue LED and a special built housing, and that housing is rated to 2,000 meters. The other challenge is going to be getting the camera systems to the bottom, but more importantly, getting camera systems back up to the top. I suspect in that area there could be quite a lot of current, and that's going to be a challenge making sure we get that combination right. So normally for every meter of water that you have in terms of depth, you need 1.5 to 2.5 meters of rope. So these guys are going to be working in 500 meters, potentially with 1 kilometer to 1.5 kilometers of rope. That's a lot of rope to manage.
When the restraints of the stringent undersea are conquered, the divers and technologies together yield valuable data.
From the BRUVs alone, we have seen at least maybe 20 or so species because we have just had little time to look through all the files. But having been involved also with the ROV surveys, I have listed down to date about 120 species of fish out of 8 dives with the ROV. With other data that we collect in terms of describing the habitat, the terrain, the slope, the water quality, then all of this information will better help describe why certain patterns, if we find any, in terms of fish communities, this will help explain these patterns that we would find.
The ability to pull together global data sets to actually analyse data and the status of fish and shark populations across greater spatial and temporal scales. If everyone's doing the same thing, then the ability to pull those data sets to answer really important questions is just limitless, and it's really exciting.
The study and all its data make the initial and partial unveiling of the mystery of Benham Rise exciting. So the mystery slowly unfolds.
Surprisingly, each site that we've gone to has a sort of like its own characteristics.
Understanding a part of Benham Rise.
When I read the report from the last expedition, I didn't believe it. They said 100% coral cover, and I'm like, that doesn't exist. 100% is crazy.
The very first site we landed on was just covered with coral, plating coral sheets just overlapping one another.
And there was 100% coral covers, giant plates as big as I am, stacked one on top of another. Just coral living on top of coral, living on top of coral.
In this area surveyed, we can see that most of the microhabitats were dominated by other fauna, again, sponges and gorgonians. And coralline algae microhabitats also found in abundance in this station.
Uncovering sanctuaries.
The corals that live here have the potential to reveal a new species that's never been found anywhere else.
There are studies that say that this could be possible refuge of fish that are found in the shallow parts of the reef.
This is the initial results that we got. We have mapped the different microhabitats using the video and still photographs taken from the ROV. And we're going to use this to identify what type of corals are found in each site. We're going to identify all the hard corals and probably invertebrates that are associated with this different benthic substrate.
Exploring the waters themselves.
Well, we basically study motion of the oceans, currents and how they vary space and in time, and also looking at how temperature and salinity distributed in the ocean.
We would like to link studies also of the water, the movement of the water contributing to what the state is of the reefs that are on the seamount.
Well, because temperature and salinity are the tracers of the ocean. You know the temperature and salinity, you can identify where these waters came from. Out in the open ocean, one of the most important functions of the currents in the ocean is to transport heat from the tropics up to higher latitudes. In the North Pacific, it's the Kurosho that does that. So Kurosho essentially controls how much heat goes up to the upper latitudes, and the distribution of heat affects how our atmosphere systems behave, how our climate and our weather systems behave. This shifting and the splitting of the flow is like a valve, controls how much heat goes to the north and how much heat goes to the south. And I think that's the key importance of this Benham area and even the area east of Visayas. It may affect storm genesis and storm strength as it propagates. There are also a lot of mesoscale eddies. These are large, like 200, 300 kilometer across whirlpools that move continuously from the east going towards the west, towards the Pacific and into the Luzon Strait and Taiwan. We want to understand what happens to them, because they might have an influence on things like fisheries productivity and stuff.
Exploring the water itself.
Do we really find as much species that we find compared to the shallow areas of the country?
The spawning fish that live here actually have the potential to help recover fisheries across the country.
Do they contribute to the populations that are found in the shallows? Or could this be a refuge?
This is one of the primary fishing grounds that are known to local fishers around the eastern Pacific seaboard.
Revealing an ecosystem rich in biodiversity on its own.
We know it's the pathway of breeding ground, spawning ground of tuna and other commercially viable fishes.
After a little while, we did find some stingrays, 2 huge moray eels that were biting at our bait. a few reef sharks, white-tip reef sharks, and just last night, a highlight came up when a huge male tiger shark went in to investigate.
What are the responses of this system that are far off, for example, to stressors like sea level rise, ocean acidification, or bleaching?
Based on the result of the first and second Benham Rise expedition, the area that was discovered was really a small area of the totality of the Benham Rise site.
The Benham Bank ocean floor that we are seeing is the tip of the iceberg.
Even with just the partial study, the discoveries already ignite the imagination.
It also may have rich mineral deposits.
It would be great to be able to identify a place where recovery can begin to rebuild oceans in the Philippines.
The discoveries lay bare a stretch of exciting possibilities.
We don't know whether there could be some other interesting things at the bottom of the summit. We haven't seen the flanks.
For all Filipinos,
The Philippines will definitely benefit from this.
and even for mankind.
The Philippines, in general, is at the center of marine biodiversity on the planet. That means that there are more corals, more fish, more different species than there are in other parts of the world. However, there's also heavy fishing pressure. And because of that, the fish in the Philippines are getting smaller. It's getting harder and harder for fishermen to make a living.
Benham Rise could help the Philippines expand its marine and fisheries resources.
You know, there's appalling poverty, especially among fisher folks who are considered as the poorest of the poor. So you cannot possibly restore fisheries, make them abundant, without ensuring that the marine ecosystems that they live on are healthy.
The fishing here is able to continue into the distant future to feed many people and help the Philippines continue to grow.
Benham Rise may be a possible source and refuge for our marine resources, a buffer against the growing impacts of climate change.
For me, it's a survival issue. And there is study which shows that the reefs in the bottom part, mesophotic reefs, and they can be seen as adaptation strategy, make the ecosystem resilient. So it has a better way of coping with the impacts of climate change, such as global warming, which leads to acidification, coral bleaching.
It's rich in the eastern side, and as we know, in this portion, the one that is most vulnerable to the impact of climate change. Sea level rise and maybe tidal waves coming from the Pacific. If we have intact coral reef areas at the eastern side, it can help also buffer the Philippines from these types of impact from climate change.
Now, devastating effects of climate change. And if we protect Benham, we give better chance to, not just to the fisheries, but to our people to cope with the impacts of climate change.
We also may have even more biodiversity than we know of.
A unique ecosystem and a hotbed of biodiversity, Benham Rise may ensure natural sustainability.
Because of its unique geological features, because it's a unique ecosystem, there may be certain biological diversity that have yet to be discovered in that area.
It is the perfect time for our decision makers working with stakeholders, citizens, to craft that management framework.
Besides the research side of the endeavor, key stakeholders involved in the Benham Rise project should get together and identify all the necessary components that needs to be addressed. Meaning that we need to identify the sustainable way of managing the Benham Bank area.
As we discover more,
I'm pretty sure with further exploration, maybe more research, not just for fishing, we'll be able to determine what's in there, and therefore that will define, the various important elements in the Benham Rise, the information that we will generate later.
Primarily because we need to get the totality of the resources of the area in order to know what policies we need to implement. So if you get only a small chunk of the area based on the first and second expedition, you cannot extrapolate that small area to the totality of the whole Benham Rise expedition. If the Filipino people would know about Benham Rise, they will protect it for the next generation.
we need to protect Benham Rise now.
So in the meantime, we need to make sure that these resources, especially the fragile living resources in this area, are adequately protected so that they can also be for the benefit of future generations.
Now we see Benham Rise, the pristine territory of the Philippines that needs protection.
Hey, there's much more down under. Let's see what there is. Let's see how we can benefit from them. Let's see whether there is something new here. Let's not stop at studying all this. Let's be proactive at it. We can't because we continue living and life goes on. We have to continue to make sure that there is something else, something new, something deeper down there. It's not only the natural resources that we are protecting. It's eventually protecting everybody.
Furtive, curious, hungry. In the deep or in the shallows.
If we want to sustain, to keep this ecosystem services providing us with what we want in future, and I think we're better off taking care of whatever living resources we have here in the shallow waters down to the deep.
In the partially known and still largely unknown. In Benham Bank, in Benham Rise. Here, there.
We can consider this as a common wealth for mankind.
The stingray, the fishes, you and me.
Benham Bank is a very special place. As stewards, we should do something to protect it. Not just for us, but for the generation that depend on us to ensure that we have a better planet, place to live in. And we have this special place in our own territory, and we hope Benham will inspire us to do something for Benham, for the country, and for our world.
We are one. We need to protect Benham Bank now.